taking seats. Which investment, the question, which investment gives you the highest interest rate? Deposits, stock exchange, real estate, what do you think? The answers? One more, okay. You were first.
Sure. AI, ChatGPT 5.0.
Okay, interesting. Other questions? Speak it loud. Wow, you are right. Absolutely right. Knowledge is gives best interest. Okay, and what is knowledge is of course education. So we know that education is the most to change the world. So this is we're starting from section on education, and education is the first step of implementing information computing and technologies. Just highlighted in the course, it first education, then research, and then industry applications. So we'll discuss some of the advancements in this important area. And I would the presentation of Oleksandr Spivakovsky, Petukhova, Anastasiia, and Maksym, three subject didactics to artificial intelligence is a modern concept of education. So presenter will be Anastasiia, and the floor is yours.
Okay. Yes. Yes. So, yes, I am glad to see you all today, and I'm really glad to present these results of scientific research. And our topic is three-subject didactics 2.0, the role of AI, artificial intelligence, in the modern concept of education. And our team, Oleksandr Spivakovskiy, Liubov Petukhova, Maksym Poltoratskyi, and me, Anastasiia Volianiuk. I am a lecturer of Kherson State University of Pedagogical Faculty, and I hope that will be very interesting for you, for educator, and for maybe for teachers. Yeah, next slide, please. Okay, the integration of AI into the educational environment is fundamentally transforming the role of technology in learning from a supportive tool to an active partner. And building of the concept of three-subject didactic development by Ukrainian researchers, we propose it a modernized version, the three-subject didactic 2.0, in which AI acts a full subject of the educational process alongside the teachers and students. And you can show this information on this slide. And our accent is active partner, not only object, not only tool. It's active partner in learning, in educational process. And next slide, please. You can see this model, and the first stage is subject-object didactic. It was classical model when student was a passive recipient and the teacher was active, and it was one-way process. And the next stage, second stage, the subject didactics, it's about the changing of this role of student, because student cannot to be only passive object. Student, it's a student, or for example, pupil in school or student of university. It's really active participant of educational process, and it was the second stage, subject didactics. And the third stage, 3-subject didactics. It was an object of research of Liubov Petukhova, and she said that the third subject is ECAP-A, informational communication pedagogical environment. For example, it can be internet or computer or technology, it can be IT tools, but it can be not only instrument, not only tools, and it can be subject. And today we want to speak about 3-subject didactics 2.0 and AI as an active partner within this informational communication pedagogical environment framework, which can to be this active observer, facilitator, pedagogical, collaborator, etc. And next slide, please. Yeah, and you can see this 3 elements. And teacher, it can be a lecturer of university or teacher at school, it's educator. And student, it can be child in preschool, or a student in university, or pupil in school. And the third element is AI, because AI can be this third element, but it can be subject. It can be active partner, and it can be this tutor or facilitator in this model. Okay, next slide, please. Yes, and we today we can speak about AI function in educational process, and for example, it's automated assessment, personalized learning, and content generation, and predictive analytics. You can show information about it, and we can the next slide. Yeah, and we know that AI today it's not only positive, it can be with some problem, with some risk. And we saw about benefits and challenges, what we can meet on this way to use AI in our work. For example, benefits, it's enhanced personalization and adaptive learning, automated administrative function, improved student engagement and motivation, data-driven pedagogical insight, scalable individualization attention, and challenged ethical concern regarding data privacy, risk of reducing human interaction, digital divide and accessibility issues, teacher training requirements, and algorithmic bias and transparency. And in our university, we have we know about these challenges, and we have opportunities to resolve this problem. For example, we have we was one of the first university in Ukraine who created a document, university politics, about use of AI in educational process, and we have some many opportunities for our teachers, for our lecturers to develop digital skills, for example, the School of Professional Development. And we know about it, and we work with this challenge. Next slide, please. And on this slide, you can read about requirements of information communication pedagogical environment for didactics, for this 3-subject didactics 2.0. For example, personalization and adaptivity, inclusivity and accessibility, and analytics and feedback. Yeah, you can read about it. And next slide, please. Yes, and we use in our research multi-agents implementation. We use Crew AI framework, and this framework enabling specialization, i.e. agents, to collaborate in educational tasks, from content creation to personalization, tutoring, etc. and scalable architecture and workflow integration. Okay, next slide. You can see this picture. It's not about not our picture, but we inspired us, and we use this idea in our research, and you can see the different agents meet different roles, meet different functions. For example, explainer agents, problem solver agents, coding, reviewer, motivator, and different functions and different roles of these agents in your educational process, in your concrete task. Yeah, and next, please. On these pictures, you can so a model of AI agents interaction in this information communication pedagogical environment, and you can say this three-element student or pupil in school, teacher or teacher in school, or teacher lecturer in university, for example, and AI. And you can see this additional element, what we included in this model, for example, knowledge, tutor agents, and different agents who can help us in this common goal. Okay, and the next slide. Implementation Ukrainian higher education. This research was created with the Ukrainian team, and we want to say about European integration that European documents had some requirements to use AI in educational process, and Kherson State University was first who can who create some documents with these requirements also. And on the level different faculty or different part of university, it can be developed, because it really can be developed in the case of administration or university administration wanted. Yeah. And next slide, please. Yes. We saw about AE as a pedagogical partner, not only tool, not only instrument, pedagogical partner who can help us, and we can maybe speak with them, maybe work with them, and to have some result. And the key questions in this is personalization learning, human partnership, and scalable implementation. Yeah, you can say it in this slide. Yeah, okay, thank you for your attention, and I will be happy to answer about your questions. And maybe
Thank you so much for presentation. Yes, thank you. Yes, once again.
No, the question is not about AI. The question about first. You've been telling us 2 or 3 times that Kherson State University was the first to do this, to do that. How could you prove that? Have you ever heard about AI Act? Thank you.
Yeah, thank you. And we have some experience in our university, but it's experience and some proposition for Ukrainian education system and for adding for масштаб for of this idea, and we talk about this conception about changes of classical model and to using AI in this educational process. Yeah. this crew AI, but it can be created with different framework. Yeah, it's some agent. Yeah.
Okay, thank you. So many questions.
Thank you for your presentation. It was interesting to construct such a model. And I would like to ask you about AI agents. You demonstrated some crew AI and some specialized AI agents in some domain. Is it mean what, for example, we have some specific domain AI agents will have some preferences in contrast of general AI? And what role of specialized in specific domain of AI agents? Can they do their job better than, for example, general AI? Thank you.
Thank you for these questions. It's very interesting and a little bit difficult questions for me. Yes, I mean that we used this crew AI, but because it helped us with their concrete adjective. But I think it doesn't matter. We can use different system and create this, but it maybe must to be subscribed in another scientific article because we have only this model. Yeah, thank you.
Okay, yeah, this and yes, okay.
Thank you for your presentation. Your presentation is based on the supposition that AI is honest partner. But now there are some cases when AI can lying. How you will control this situation? Thank you for your answer.
Yes, thank you. It's really they're necessary today for science and for education and for AI role. Yes, I think we have some problem with ethical questions, and with this some hallucination AI. Yeah? It can lie and it can to be wrong, and we must check it. And it's a key questions because it's tutor, it's helper, it's facilitator, but we must with them in active act, and we must to check it. And after that, after checking, use this information in our educational process. The main decision must, thank you, take person, people. In this case, it's a teacher or educator, but in acting in when a student use this instrument, student must check information too. Yes, but the main is the only human. Yeah, thank you.
And the responsibility.
Yes, yes.
Well, actually, that covers my question. Thank you very much for it. But I wanted to highlight this responsibility point. So when we talk about the AI Act at the moment, we have this collaboration and then a subject. I didn't get exactly the meaning of the subject in this equation. Thank you very much.
Can I have no. It's close.
It's Kukuosa. No? Okay. Sorry, Oleksandr Vladimirovich. Okay, yeah. Thank you. It's it's necessary and about these questions we have in our article, but I think it's the common, it's bigger questions because we use AI or we act with AI. For example, when I use some tool, for example, I use some prompt and I have some answer. Okay, it's this end. And if I have some answer and I can act with this answer and to add some corrective, it's like a speaking, but I must to have some responsibility and I must to check this information, but it's like a speaking and it can be really some active participant of this speaking because I can to have additional details or additional questions and it changed my result of my work with them.
Thank you. And the last question from our special guest, keynote speaker of the course.
Thank you. Thank you so much. Thank you for the presentation. For me, it was a little bit too abstract, I'd say, too high level, because there are so many unanswered questions in this presentation. So you mentioned that you used Chukhray AI, for example, for the proof of concept, if I understood correctly, and you already tried integrating it in the university. Is that right? Yes. Okay, good. So let me start there. Which specific models have you tested with Chukhray AI? Do these models speak Ukrainian? Are these models adapted to the cultural and historical context of Ukraine? Have you actually tested that these models can act as a tutor, like the student to the answer rather than giving the answer right away, and whether they can be adapted to the actual level that the student is studying? So, like, I have some technical questions about the implementation that weren't even covered in the section, in the challenges section for you. So, since we don't have much time, like, pick any of the questions that I asked right now, and maybe you can elaborate on any of them. Thank you so much.
Okay, I think that thank you very much for your questions. Yes, we used in this research only Chukhray AI, but
have written article. For me, it's just interesting. It's what AI think about this article. In first step, we must use AI, but use as recommendation, which it's understandable. That's why we built the new system of coordinate, where is we embed AI in this system of coordinate. It's the main conceptual idea of this article.
The idea makes total sense, and I'm happy to hear that Kherson University was the first one to have the recommendations like this. Because currently we have like recommendations from the Ministry of Sciences and the Ministry of Digital Transformation of Ukraine, and like part of development of these recommendations that can be applied in all the universities in Ukraine. I was mostly wondering about the proof of concept, because like the theory has to have a way to be implemented in practice. And you know, if there's no underlying technology that is ready yet for this theory to be implemented, it opens a whole list of questions that maybe the theory should be modified a bit.
Yes, I
Right.
understand.
Yeah, we can take it.
Thank you so much. It's a good, thank you. It's a good idea that so many questions have been raised. Yes, thank you. Thank you. And I will the speech, diagnostic models, and a crypto-based science economic approach to enhancing motivation in intelligent mathematics learning systems by Andriy, Chukhray, Oleksandr, Ludmila, Mandrikova, Tetiana, Dehtiarova, and Havrylenko. So it's yours.
Precise knowledge diagnosis and motivation system that reward meaningful learning, not only like correct, not correct. So in math, we have such difficulties, such challenges in difficulty of the subject, and as well discouraging because it's boring, and many students disengage aiming for minimum efforts, especially in the conditions of existing ChatGPT. So current intelligent tutoring systems often focus on correctness, ignoring signals like analytic capabilities, ability recovery after mistakes, and student components or two layers. The first is a hybrid tracing engine, discrete models for clarity and control, continuous models for the subtle changes. And the second layer translates the signal into recognition, personalized task, feedback, and tokens. So this way, motivation is tied directly to diagnostic results. And as outcomes, we have personalized feedback and tasks, transparent recognition, and sustained motivation. Okay, thank you. As you can see on the comparison of existing models, discrete and continuous, discrete tracing like Bayesian networks models works with less data and is easy to interpret, but it's not precise enough for the educational purposes. And continuous tracing like deep learning embeddings is sensitive to small changes but less transparent. And our idea was to combine them, keep the clarity of discrete models while capturing the some features of continuous ones. This is especially valuable in mathematics, where reasoning is stratified and we cannot, no student cannot come to another step before they have not completed previous and correctly and understand how it get this result. So next, please. We maintain two synchronized traces, and this is discrete trace, checks skills and verifies solution steps. And continuous trace tracks behavior such as time on task, retries, edits, and so on, and fits a deep model. Deeper model, next level model. By fusing both, we can update mastery, update on each step, mastery probability, and adapt feedback more precisely. Next. A key element is structural error detection. And we parse the student solution as a tree, first according to signal parameterized approach. We parse the student solution as a tree and compare it to correct some correct or etalon structure. When the first divergence appears, such as wrong signs or missed operator, we classify it and map it to specific skills. So we define which skills is not so good in of the student. And this leads to precise feedback and targeted hints. Next slide, please. Here you can see mathematic model of the tree, which represents student solution, like some nodes deal with edges and with some weights, not weights, but labels. And as well, we define First, structural divergence, which shows whether it exists errors or no, and if yes, we will have non-zero this divergence index, and then we can classify this error according using diagnostic models corresponding and translating these tree and this index like out from threshold, this index, and to the concrete diagnostic models, which gives us information about what's wrong in their students' reasoning. So next, please. So in the behavior vector, we store such parameters like time, hint request, retries, idle time, and effort variation. These signals combine with mastery probability into hybrid score, like presented here according to this formula. And the score, this score, it's not a grade, it's some mark or guide for recommendations for visualize progress of the student and recognition events or recognition of students' state in this moment. So next, please. So we define senses as meaningful contributions to learning beyond the correctness, such as it may be as examples like structural errors, persistence, recovery after failure. So what student, how it managed with their error situation, teamwork, creativity, reflection, and so on. Each sense has a weight and adjust recognition according to difficulty and effort. And this supports motivation by linking recognition to autonomy, competence, and collaboration. Next. To make recognition transparent, we use some physical, not physical, again, it's like digital measure sense coin. It's an internal token on a permission blockchain. Tokens are issued for verified learning actions such as correcting or conceptual errors. Student can use these values, these coins, for educational some purposes like some resources, mentoring, or projects. This creates some meaningful, closed in the frame of the certain university or maybe department of university economic system, which gives something like a game approach for students. And next slide shows example of shows where is preview? This slide shows architecture of the system, and architecture includes 4 modules: student interface, which contain tasks, explanations, and hints for the student. Second model, diagnostic and tracing, knowledge tracing engine, including both discrete and continuous models. Third module, sense mapping and valuation, which converts HSS to senses. And the last blockchain layer with mining of sense coin and record and manage of these questions. Next, please. And here you can see example of how looks such a model when a student solves differential equation of the second power and second order, sorry. They for instance, he misclassifies the roots and then correct themselves without hints. The system logs the error, the self-correction, and the persistent. So these values of the vector. And mastery increases, effort is recorded, and hybrid score crosses crosses the threshold. And student receive as answer recover cents and 0.5 cents coin and explanation of his what is wrong with his solution. This recognition is stored and maybe used in the further. So it will be as well accounted in the next calculation of the scores. Next, please. So the proposed approach has strengths and opportunities. First, it's personalization. Students receive feedback and some value-based estimation of their efforts, thinking efforts or educational efforts. Transparency, next, the formal structure of knowledge detection gives for tutors trace learning progress step by step, both for students and tutors. Motivation innovation is this sense coins, which we offers as a path to their sustainable engagement after not by the correct answers, but after some recognition of the students' efforts during all the task solving. And extensibility in the sense that architecture of the system is modular and it can be embedded in different learning management systems or university services or make maybe some mobile application. Next, please. And as well, this approach, as we can see, and as we have analyzed, has its limitations, which deals with, first of all, fairness in the sense of assignments across the courses, or we need to cooperate, some cooperation among tutors, which scale, make the scale for the each of their students' efforts. Then token system should be some managed by a department or university, and as here stated at the last sentence, that tokens is very like tricky things that may lose perceived value, must be investigated in some way, so it must be some physical or digital base for this. And balance of motivation. You know, when you begin to give somebody external motivation, he will use his internal motivation. So these coins may be like another side, not so good as motivate. Subjectivity of sense mapping, this sense which we try to convert to some values, it's like experts, so tutors or some administrative a personal should state these sense values, and it may be enough like contradictional question. And no, yes, standardization of this process also some issue for the further maybe discussion and researches. And next, summarizing the given information, proposed approach. Next steps must be in extend sense taxonomy, automate calibration this, so introduce some data-driven methods. Next, it's practical application and introducing math courses and real situation, look at the real situation, like the real students will react on this system. And create some interface for formal verifiers for embedded these existing models, which are realized in modules, must may be embedded in the existing learning platforms and applications. So next. Thank you for your attention.
Okay, thank you for the presentation. I say first speaker, of course. Do you have questions? We don't have time for many questions. Once again, who haven't answered previously? Okay, we start from.
Thank you very much for this very comprehensive report of your research results. But I did not catch what about blockchain? Why do you need it? Maybe it is possible to do without it. And what is the reason of this?
This idea, he's interested in this topic, and he proposed introduce it like motivate students. So give them coins by the same rules that acts in the Bitcoins.
The same rules. I see.
Yes, use this
I see.
like creation, but some question like the real bitcoins may be mined. For instance, mined by. This is like using like a game, yes? Yes, it's some element of gamification of the process. Thank you.
You mentioned about investment of the real goal in this way. Okay.
Thank you so much for the presentation. I'm all for gamification in the education process, and this idea is very similar actually to what is integrated in 2,000 schools in Ukraine right now, like starting today with Mria, because the Mria app allows pupils at schools to earn this which they can then use to buy like cinema tickets or sweets or something like that. So that's great. It's a very similar idea in that perspective, and I'm like all for it. I was going to ask you about the underlying technology behind the engine, the diagnostics engine, I think it was called in your presentation. Yes. So like, how are exactly these hints and answers generated for students in mathematics?
These models based on the signal parametric approach, which allow using signal, so output from some system, classified errors and give the deep diagnosis, including the place of error, class of error, type of error, and kind of error. So it may be this then in mathematics in this part of the equation, and it's missing or added some extra or replaced or calculated wrong and so on. And concrete value of the how we need to change to have right solution. And these diagnosis models like activate by the out delta, this calculated value based on the error, based on the HSS value. It gives us some signal, and we interpret this signal as concrete. It will give us place, type, and kind of the error of the student. No, what about testing system? We just have a prototype, so we test only by our team, maybe not so wide.
The system against and then get some accurate.
Yes, no, so we need some complete application, or those that I've said about future investigations, researchers, that we need something that test not on the bigger auditory. Yes, it's in.
And conventionally was sort of out of time, so maybe we should move to the next presentation. And understand that there is no like practical implementation of this idea. It's just an idea research.
Modules exist, and each modules tested, but in the whole system and how it embedded in it's only question.
Okay, I mentioned Maria, which is pretty similar, and some startup which make it is the same, but it has burnt out. So thank you so much. Sorry, all these questions, yes. And some presentation. And the next presentation is in 15 minutes. based on semantic web technologies from Oleksandr Spivakovsky, Maksym, and Revenko. So, please, who will be present?
Okay. So, good afternoon, dear colleagues. It is my pleasure to present our research model in an individual educational trajectory for adaptive English language learning based on semantic web technologies. At Kherson State University, we are working on the problem of how to build truly personalized learning trajectories for students. And in this project, we asked ourselves how we can design an adaptive system that recommends the best possible learning path for each student. And our solution is to apply ontologies and semantic web technologies tools that allow us to structure knowledge and generate personalized recommendations. In higher education, English is often taught in a rather traditional way. Students follow the same curriculum regardless of their initial level. Feedback is often limited or delayed, which slows down adaptation. And formal courses are usually separated from other opportunities, for example, from speaking clubs or online platforms. But if we look at what is possible with digital technologies, the picture changes completely. We can design adaptive trajectories that take into account the student current and target level. We can provide real-time recommendations instead of waiting for the end of the semester. And we can integrate different learning environments, university courses, informal clubs, MOOCs, into one coherent pathway. And most importantly, the focus shifts not from teaching content, but from the students' individual goals and needs. And this contrast shows us why we need a more advanced technology-driven model. And this is what our work is about. When we analyzed the situation, three main problems became clear. The first, students enter the university with very different English level. Some starts from A2, others are already at B1 or C1, and designing one curriculum for all of them is almost impossible. Second, many so-called adaptive systems are in fact based on static recommendation algorithms. For example, Duolingo simply repeated similar tasks when students made mistakes, but the overall sequence of learning remained fixed. Standard Moodle courses often work the same way. They guide students through a linear syllabus, sometimes offering a taste-based tour, but not building a personalized path. And even MOOC platforms like Coursera or Udemy mostly recommend courses based on popularity or previous clicks, not on the learner's actual proficiency or target level. In other words, this system may suggest models, but they cannot dynamically construct trajectories that evolve with students' progress. Our goal was to design a model that builds individual educational trajectories for students learning English as a foreign language. The idea was not only to personalize university courses, but also to integrate multiple sources of learning. Formal courses at our university, informal activities such as speaking and book clubs, and online courses from platforms like Coursera or Udemy. And the central innovation here is the use of ontology and semantic web technologies. Why we choose ontology? Because it allows us to represent the educational ecosystem formally, who student is, what their current target level are, and which courses, clubs, or MOOCs provide specific competencies. On top of the ontology, we applied semantic reasoning to automatically generate recommendations. This way, the system doesn't simply suggest a course, it can construct a trajectory step by step that evolves as the student progresses. To construct an individual trajectory, we need to define which information sources would feed into the model. First, formal education. These are English language courses that are part of the official university curriculum. In addition, students can choose elective disciplines that match their professional interests. Second is informal education. At our university, we have developed a very rich network of language clubs. For example, the KSU English Speaking Club with the University of Kent and other many speaking clubs and book clubs. And third is online learning. Here we include MOOCs such as Coursera and Udemy. And students can follow courses aligned with their CERFR level from A1 to C2. And also take professional English modules such as English for IT professional or business English or any other modules. The first step in constructing an individual trajectory is to understand where the student is starting from. And for this, we design an online placement test. The test is very standard. It has 4 components: reading, grammar, vocabulary, and writing. Together, this gives us a very accurate picture of the student's current proficiency. And the results are mapped to the common European framework of reference from A1 to beginner, from A1 beginner to advanced. So this level then becomes the input data for our ontology, for our model. Why is this step was important? Because from this point forward, all the reasoning and recommendations are based not on assumptions, but on formalized data about the student's skills. The model receives the student's current level as one property, and later it will match with the target level and available courses. These steps ensure that the whole process is data-driven and each trajectory starts with an objective evaluation. So this placement test is not just evaluation, but the starting point of the entire model. We define several core classes that represent the main entities of the educational process. First, the student class, which has properties describing the student current English level, the desired target level, and the basic identifiers such as name. Second, the level class, which represents proficiency level from A1 to C2. And the third, 3 types of educational objects. Discipline, which represents formal university courses. Speaking club, set, which refers to informal opportunities for language practice. And course, which includes MOOCs platform like Coursera or Udemy. The connection between these classes are established through semantic properties. For example, to provide links and educational objects to the level of English it supports. The properties offers university discipline and offers university informal, connects the university with courses and informal clubs. And informal education links the external platform to the online courses. In this way, the model captures the structure of entire educational system at our university in an informal, machine-readable formats ready for reasoning. What really can make the model effective is the system of semantic relationships that connects. We define several key properties. Offers university discipline, which links Kherson State University to formal courses. University informal, which connects the university to informal learning opportunities that I described previously. Informal education and to provide which links any educational object, whether a discipline, a club, an online course, to the English proficiency level that it supports. This relationship allows the model to do more than just throw information. They make it possible to reason about connections. For example, if students aims for the level B2, the model can automatically identify all educational objects that support this level, where they come from the university or informal learning or online platforms. We designed the model with flexibility in mind. It can support different types of goals. Of course, it can model progression along with the CEFR scale from A1 to C2, but it can also be easily adapted to exam preparation such as TOEFL or IELTS or Cambridge English by adding corresponding levels into this model. It is also expandable in terms of resources. New discipline at the university, new clubs or MOOCs can be added without breaking the structure. And the model also allows for richer description of educational objects. Beyond just a title and a link, you can include metadata like duration, costs, authors, and so on. And finally, because it's ontology-based, the model is scalable. It can be reused for any other language, foreign language, or integrated into the digital ecosystem of other universities, not just ours. At KSU, we are preparing to integrate this model into our corporate electronic service KSU24. We are planning that it will act like supporting model that generates personalized recommendation, combining university courses and formal activities according to the students' needs. Another planned step is integration with our AI-based chatbot, Yeva. Through the chatbot, students will be able to interact with the system directly, asking questions, receiving personalized advice, and even consultations adapted to their current level. In this way, we will try to move the model from the theory to practice, becoming part of the university's digital educational ecosystem. The model brings several important advantages. First, personalization. Each student receives their own trajectory that reflects their current English level, their target goal. The model doesn't only rely on formal courses, but integrates all three environments: university, informal learning, and MOOCs. The second is automation. Recommendations are not written manually, they are generated automatically, which both saves the teacher's time and guarantees consistency. The scalability and flexibility that I mentioned before. And together, these advantages make the model both academically robust and practically applicable in digitalization for education. And to conclude, we designed an ontology-based model that builds individual English learning trajectories. It integrates multiple educational environments into the one pathway. Their recommendations are generated automatically and adapt to the students' goals. The model's key advantage are personalization, automation, scalability, and logical consistency. And this model can be a step towards building a more flexible, more adaptive, and truly student-oriented digital learning environment. Thank you very much for your attention, and I will be very happy to answer your questions.
Thank you so much for the presentation. Okay.
Thank you very much for making a tendency of bringing up more formal things in educational papers. This is, well, in my memory, with respect to Victorian community, seems to be the first educational section which has been speaking about conceptual and technical aspects of knowledge representation, AI, and reasoning in education-related applications. To the questions now. According to Tom Gruber, whose name you know, I believe, ontology is a formal shared explicit formal and shared representation of conceptualization. Does your ontology follow these Gruber's principles? How much is it formal? How much is it shared? And how much is it explicit? Explicit.
Online guest doesn't hear it. So please.
Well, thank you for your question. I think since we use the ontology and it should be pretty much formal, it cannot be not formal. It's very structured, and I believe it is explicit.
Just next question.
Yeah, thank you very much. The role of personalization is really
First step, I describe it that the first step is to define the level of the English proficiency of each student, and then the model can recommend all three ways to learn English, and that's why it's personalized, because the system recommends the best way to the students to reach the targeted level. When we are in the university system, we're all the same. Nobody defines our English language level. Nobody defines what as a target goal. We want to use English for IT or business or any other purpose. So this system can structure it and make the way of learning English more personalized. Firstly, by defining the level, and secondly, by proposing the wider range of courses that is personalized with personalized recommendations for each student.
Thank you. Thank you. Do we have more questions? Yes, Mariana.
Thank you so much for the presentation. Since you mentioned the Common European Framework a couple of times, and you're referencing like using the Common European Framework of levels of the language knowledge, I wanted to ask you why you don't evaluate students speaking. You mentioned the relation of reading, listening, writing, and grammar, but the Common also includes speaking as one of the tests, and there are multiple online tests that you can actually take.
Stop.
Because for now, we actually don't know how to evaluate speaking in this model, because it's face-to-face process. And we don't need only the machine to evaluate speaking. So it's for us, it's a bit hard to evaluate speaking. Maybe we can find a way to develop, to find solution, but for now, we're not on this stage.
There are multiple available solutions for the English language specifically, so I encourage you to dig deeper and research them. You can use them in your system.
Okay. Okay, thank you. And if no more questions, I have one question. How to transfer all your research to other disciplines? I don't know, the mathematics we mentioned it often today. If there are some ideas.
I need to think actually, I don't know exactly. Maybe using the logic rules and free logic rules and ontologies, but the person who defines this and model should be mathematic or any other specialist that will create rules.
Understand. Thanks. Thank you for the presentation. This was the last presentation of the session. So thank you. And for the presentations of the session and a fruitful discussion, which will continue, I'm sure, on the coffee break. The current education is education tool, but education is life itself. And so, and when you used to a school, you have a job. School is a prison. Make your choice.
I've already made this important conceptual choice. Please open up to accept more useful information. Coffee break will be ready in 5 minutes from now. Enjoy.